explain to Linus, because is in Australia over there. He's still, I think we should switch to him because he's got the honor of having the last presentation. So what time you want? Given that it's already 11:30. So please go. Stage is yours. I wanted Linus on behalf of Linus himself, of course, and am I pronouncing this right? And they're both at the Design Factory Melbourne. What it is, whether it's a department, institute. In any case, it's contained by Swinburne University of Technology. So you're in deep winter. Thank you for staying on for so long.
No problem, thank you. Yeah, so my name is Linus. Switched to the School of Design at Swinburne University. So Design Factory Melbourne is an innovation hub that's part of the Design Factory Global Network around the world with the same design principles. So you can kind of Design Factory Melbourne and university's design factory get going, because it's a very nice way to kind of move around. But so that's kind of Design Factory. Yes. Okay. So before I start, I just want to pay my respects to the people of the Kulin Nation, Islanders whose land I'm speaking and presenting. I pay my respect to their elders past, present, and I'm gonna move this one. Okay, so what I'm presenting today, kind of about wicked learnings of wicked problems. It takes a step back and on the individuals, how you interpret problems itself. It's a few presentations, but the ones that Ben was talking about, I also it resonates deeply with me. Well, this presentation is a theoretical one. Wicked learning. I was looking at cognition. That's my area of research. So how people, how designers learn about problems and attempt. And just one last interesting. My research is also in artificial intelligence, and the back side was mid-journey and visualize wicked problems, and actually quite beautiful. Anyway, so what I'm going to today is just when I read about problem-solving theory, the term problem-solving, it suggests that it can be solved. Wicked is more of an emerging concept from learning organizations, and just think about in terms of wicked learning environment, or design in wicked learning environments for wicked problems. So I left out references, but they are self. So back down to Newell concept, talking about problems and problem solving, because that actually also informed the discovery of sometimes are not tame problems. Okay. Alan and Newell's what they call problems within a problem itself, and they call it the initial desired state And I like this way to describe. It's not suggesting there is that what's the initial state that we are seeing it, and what's the final desired state that we want to see it become. People who actually take the actions to turn the initial state components to a problem which they defined. But when it comes to in relation to human, this goes in the initial states and final. You're already changing what the problem. We are also representing it. So how we represent will shape it very different to what it actually is. The operations that we then the third factor is, and if we lack that knowledge, change the initial state to the final design. And then the fourth bit is to enact those operations to turn initial states to the final desired state. So when we talked about wicked problems, it's about wicked problems from well-defined or tame problems towards the other end of ill-defined problems. Visualizing the initial I can through diagram. There's also with problem presentations that are well-structured and ill-structured problems. So particular image that those same as the ones below, just kind of messed up, discombobulated. It's always, I think, there is no ill-defined, well-structured problems. So I'm AKA or specifically is this, you have no idea what it's trying to say. So when it comes about human problem solving theory, and I think Christian, I also agree, like you problem solve quite a weird term. It be solved. And in the paper at that time, I was thinking problem solving. A research that was calling problem scoping, which I kind of liked it a bit more, but there was so much that's on problem scoping within problem solving itself. So I also found that a bit, maybe that's for another paper. So when it comes to, and it's going back again to Allen and Newell's, they mentioned something about means ends analysis, which it is, we get information, some state, and then we jump to the final desired state to work out what is step 3. What are the operations needed to transform? And I just want to mention, is at the time, AI systems, and they did develop the first 2 AI programs. And in order to make the AI actually, this is the initial state that you're given, have to reach, the computer system will work out all the operations. So that was this approach. Step 1, step ordered in this particular way. But there are some challenges in solving theory, kind of fits within the well-defined or ill-defined problems or wicked. And the second challenge is there is also fragmentation. Conklins, there is the forces, multiple stakeholders are trying to solve the problem. So saying about social values is what's it, personal. You have so many stakeholders in the room arguing, so we're never getting a perfect or full picture of what we're probably getting, the one who says that. So there is a discounted or perhaps not even to talk about it. So this kind of human problem solving theory, that's when we try to solve not everybody's voice, which then kind of, just in this diagram here, you only see part of the problem, part of the wicked problems. Okay, so the third part is about because problem components, there's initial, and then there's final, and then we have to decide what actions to take to, so how do we actually decide operating problems? So for example, 20, when we know the question mark we're trying to achieve, and so we're trying to, at this stage, decide what the operations are. The simple ones, 15 times, 21, 20, 15. So operations, and this is where when we get more like smart, more mature, we have multiple options of doing in the problem space by using a calculator. So typing in calculators. So we do manual calculation one, or we can try visual. You may not be familiar with, quite confusing, but it does work itself. So there are multiple options of and choose to, and how we patients is based on the amount of cognitive load that we can bear trying to solve these problems. So there are three types. The first one is intrinsic cognitive, which implies or is associated. So for example, this is, and it will hold in my mind that it is multiplication. There's the load as well, which means numeric representation, and a germane cognitive load. So the cognitive load, I forgot how much your brain at one time. Once it surpasses that cognitive load, it's like, so understand 1 times 15, the multiplication, we know it, it's give you a high school 1 apples that has 15 seeds in each of them, how many seeds in total, that kind of complicates. And the familiar with using calculators. Options, we always jump back to option 1, use a calculator, we get the most accurate answer. So if we're trying to draw that, it's too much to not only understand or to, it's just too difficult, down to using a calculator. Planning operations, and this is how moving from the well-defined to a well-structured divided by 2 times 1 plus. If you multiply with the operator, because I came in quite late, but I think Tom and Ben, you're talking about, mentioned a comment about finding the problems. I hope I didn't get it wrong. Idiosyncratic, and I can turn a well-structured problem. Yes, it gives me 9, but I can also make it this way and turn it into a wall. So from a well-structured ambiguity, or I get 2 possible answers. And 9 and 1 is depends on what kind of order of you're using. Most of us will be very 1, because this is kind of the 1800s or so, but it was actually slightly different. Not, I think it wasn't that fully used yet. And so if you use scientific calculators, those calculators give you 9 and the other one will give you 1. Fun. Aside if you do this AB divided by XY, it's quite supposedly the first one, but then it's the second one, which is slightly off. Giving this option when how well structured or how it actually affects the operations itself that we choose. Divide by 2, times. If you introduce them, it will structure it, which requires more information in order to solve it. Ill-defined problems where everything's discombobulated, and your final desire. Cognitive load is just too to try and of these. Was talking about actually designers, and I think it was, I can't remember who was the author. Use heuristics to find problems or design outcomes, and there's representative and availability heuristics. So and I'll talk a little bit, I'll give you examples of what they but familiar with problem framing. Problem framing was Doors, and I can't remember the other author. But there's also a different meaning frame. So one is a problem. I also find that understand how they perceive problems and perceive outcomes. It's only one perspective. So the wicked learning environment in well-defined, the feedback is accurate. We know for sure that it will give me the right answer, and whatever we that's the right answer. It's ill-defined where everything's really, we're actually not getting accurate. So when we have these heuristics that we depend on experts to go, and let's say we design sustainable architecture, available going to Google to search, is this a good start? Because we don't know that is accurate. And Tom was saying right or wrong. I also was debating term to use to replace good. Is this the right start? Yeah. Representative. So this is where the feedback comes back. If I search sustainable architecture, you see on Google a lot of, is that a good architecture? Assessment heuristics, measurement, is that a good framework to measure sustainability? And if this is what our students learn about how to solve wicked problems, but not ever step in it, is this the right, or is this the most heuristics to use and rely on? Then we're kind of stuck in this feedback loop on this, trying to address an environment that doesn't give us accurate feedback. So we just kind of, yeah, stuck in that loop. Should way too much. This part here, I don't have any other wicked problems in wicked learning environment. Do is only see what papers and try to match it. Mayor design, and I think in the early papers she wrote search to find a solution. Problems you explore to do two things well as you can, and then Doors also worked on it, the co-evolution of design. They own space, then they move and trying to match it up and developed and the solution. it comes to wicket explorations, and here it's, the exploration is to do two things, is to try and define the problem better, of going through the problem frame and meaning frame. And again, this here is kind of it is heuristics, which might be a problem it's in itself. Being just because we see it, say, it's right, it is right. Solution model, the second paper, kind of the third paper, was saying that it's not just but also developing the solutions on its own. If we think about in a where there's problem between each time we understand or solution, the heuristics being activated, and the feedback is not to be an accurate feedback or not. One where I think Dawes in 2015 was talking about on his observation of a design team, came to a point where solutions not the right solution, and he had to reframe the whole problem, and then came out with a total getting slightly better, and was thinking about how to retain the wicket problem space is since that we are coming up to solve the problem, but to try and define a certain aspects, and perhaps all these problems are just there to help us understand the problem and not solve the problem.
Always have questions. So, Linus, you say solutions to problems, but then you give us your beautiful that has everything is invariably to the right there, either a will or a solution with everything. Yeah, how does that work together?
Yeah, I think it's because I'm not taught, but been told like, so what's your project supposed to do, or what's your research trying to answer? Like, okay, I'll just write that small programs, and you feel like you probably get a sense that I love talking about the problem itself, and I don't really the teaming bit. But I just thought I left it out there. What you think about it? A solution.
I just thought it was because are you not liking to talk about a sorry, you are in the state when it's still wicked, or whether you inherently believe that all could be solved or to become easily. It's the second, which and yes, I believe discussion with Alexander earlier in of what we call tame, we have already established kind of accept and but it's all just temporary in the sense of Brian, we work with this, but in the back of our minds we know that if we wanted to, we could spend the time it. And Ben put his hand.
Yeah. Yeah, really appreciate of the like Google and sustainable architecture and the framework. Really, bang on. Like a lot of these colleges being formed, productive of our criticality, and like I think other ChatGPT programs which produce things that are most probable, which I mean, my theory is very amateur, but like I thought information was inversely proportional to probability. So I think there's like there's those kind of feedback loops. Interesting that you're kind of connecting, but I think it's kind of shape of them, and particularly with something like sustainability, it's all shaped by I think it's all shaped by attention. Like, oh, don't worry, we all have the others, because it operates over so many levels. There are kind of the world type actually just destroy the world in other ways. So I guess that what your page reminded me of, and the work is how expanded for those feedback loops too.
Yeah, I think the sustainability was something that I picked up because I find that asking our students to learn to demonstrate sustainable architecture within 12, like this is semester long, hours a week at most. What's the likelihood of them actually giving something, designing something that by the end of the semester 6 times, and when they graduate, it kind of reinforces that, yep, I am delivering. I'm not sure whether that is the right, or that's the, yeah. But yeah, talking about reinforcing their learnings, whether being reinforced with the right, accurate feedback.
I would refers to back to something that we discussed earlier today, Linus. I'm not quite sure whether it was part of Alexander's work or whether it was Kwan actually giving his opening address. But we trust between Herbert Simon interested in taming for the benefit of computerization, and Rittel and Weber who approached the distinction between wicked and tame, not with an pulled everything toward with an appreciation the wicked, and you may fall into the Herbert Simon camp. And what you said about you being a researcher in this area seems to play a role here. Few observations. Number one, to illustrate kindness with from arithmetic, algebra, mathematical form, the epitome of taming. You use the ultimate to illustrate the that is curious choice. I think to make some points is an interesting choice. And I also suggest, I don't think we will resolve this tonight, but I want to suggest use that structure three elements that you keep going back to: the means ends analysis, human problem solving theory, and how that reflects the archetypical neural network of your mind when you talk about that. These are two of which are usually more visible and one being more flexible. And I would argue is actually an artifact. Careful, I think Alexander might jump in here and defend his Greek heritage, but this is this recurring image is actually a syllogism. Major premise conclusion or another dominates Western modern thinking. There is a narrative that weaves through philosophy around the road, and how with our desire to accommodate circularity, we are crossing into this, which is people increasingly try to find in terms of circular patterns, linear ones. So syllogisms and syllogisms comply, not permit, because there are that result from circularity. Moment early on in the 20th century when Bertrand Russell was writing the Principia Mathematica, trying to clean up the whole foundations of, wrote in his autobiography years in front of a white piece of paper, trying to the logic with paradox, and eventually he gave up. He decided that paradox is forbidden and circularity doesn't exist. Even we breathe in, we breathe out, it's migrate, and the blood circulate sort of seems to be doing, but our formal logic know how to deal with that. And then there's the moment Gregor points out that the problem with syllogism is that it is once temporary time, once we acknowledge time, actually we don't need to fight paradox anymore, because we are not looking at spirals through time, not really contradicting each other. And that kind of spiral back and forth way, this negotiation, yeah, what Brian was talking about before, that idea of keeping going in time, I think is a very important recognition in the context of ethics. And I'm on syllogistic structures preclude that, not to, but because cultural into your work, the structure of and neural networks, and that might be a limiting factor in the image that you are. Does that sort of make sense?
Yeah, definitely. And I think it was also intentional, because about the problems and not the solutions, which is, that's my area of and keen to keep. I think the whole point of learning on is to in the way we solve problems to try and find new ones. So that's the equations to show that even though it might be maths, it's quite tame, structured, and it's the whole point. Okay, that's a learned. We need to unlearn, and how do we actually unlearn and relearn certain other things? It's not about giving us that this is how we learn. It's time to can we learn something else or learn a different. But yes, it definitely biased the way I put forth the wicked learnings.
I think this is a very that structure is, and the to things, right? Taming, undeciding. Mentioned Gregory Bateson, so this Linus put one of Bateson's pieces is My Grass, and it's about reversing the typical syllogism structure. And this is becomes an inductive logic rather than a deductive one. Like what the kind of backward, through your diagram, but also through you making your diagram is like pretty interesting, I think. The unlearn idea, it might I don't know if you looked at that, but I think it might open up kind of series of other references that are.
So looking at was figuring confidence. But what was Gregory Bateson? What was the title again?
It's an essay called Men Are Graph. So
okay.
It's yeah. So I think if you that would come up. I enjoyed your algebra thing. Like, I think it's interesting to find these things within our kind of within, and I sometimes like referring to the ambiguity about parallel postulate, and that like that's an example of something that's kind of you can kind of you could have a different assumption. So I think that there could be interesting things around maths, and because you do get can be swapped around, constructed culturally in a particular like they can't be. And of course the Gödel reference that's in theorem, which is where the mathematical ways that can contain themselves, and this is an avenue with your diagram to construct your diagram in your diagram of your own process of doing the to become a paradox generator. Yeah.